Alright, here we have a pretty standard flat friction problem. Okay, we got a soccer player celebrating after a goal, doing the whole double knee slide that soccer players love to do. Soccer player, she's starting at 7 meters per second, and UK is 0.9 between her and this field. The question is, how far will she slide before coming to a halt? Okay, so this is a flat friction problem, as in like we're on a flat horizontal surface. I guess most of the time friction is going to be on a flat surface, but this is going to be a flat horizontal surface. Okay, and so to do this, we want to again looking at forces split into like kind of like two dimensions. Okay, now oftentimes we can skip one of them and just kind of like blow past it, but to be real clear and real perfect with everything, we want to go split into two directions. So we've got our up down and our side to side direction. Okay, we'll say left right instead of side to side. So for up / down, we have two forces, Fg, which is going to be the mass of the player times gravity, and this is going to be down. Okay, and Fn, which is the normal force. Okay, we don't know what the normal force is, but we do know something else. We know that F net is equal to 0, and that's equal to Fg plus Fn, because F net is all the forces. Okay, so if this is true, and we're going to make Mg, we're going to make down negative. Okay, so this becomes negative Mg plus Fn, and which means that Fn is equal to Mg. Okay, and it's going to be up, I guess. All right, so what about left-right? So in left-right, there's only one force, and that force is the force of friction. And the force of friction is Fn times mu. In this case, since kinetic friction, it's mu k. So we get m times mg times 0.9. Now, because that's the only force, F net is equal to all those forces added up, which means it's just equal to Ff. Now, that gives us a net force of 8.82 times m, where I've substituted in 9.8 for g. Okay, from this we can get the acceleration, because we know F net is equal to ma, and this is where the m cancels out. So a lot of times you're not going to have the mass in these problems, and that's fine, it's going to cancel out eventually. So we get a is equal to 8.82. Now we have to make a decision. Okay, we know the velocity, initial velocity was 7, and we know the acceleration is 8.82. But the question is, what directions are they in? The acceleration is opposite the direction of velocity. Okay, so the absolute value of the acceleration is 8.82, and we can decide whether we want the acceleration to be positive or want the velocity to be positive. I'm going to stick with the velocity being positive. So we get v equals 7, and the acceleration is negative 8.82. And again, we know this because the acceleration of friction is always opposite the direction of motion. Okay. And then we know that v final, sorry, it's v initial, and v final is 0. And now we just got a kinematics equation we can plug it into. V final squared equals v initial squared plus 2a change in x, and we should get that x equals 2.78 meters. Okay, so again, the key here was splitting into up, down, left, right. Now, a lot of you, for this one, you might skip ahead and just know the normal force is mg. That's going to happen a lot, but it's not always true. Okay, and then once we go there, we can get F net, find the acceleration, and go to kinematics.